Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a topic in mathematics. Of course, this topic is concerning with the equation of a straight line. We're going to see that this concept of a straight line is very important because in different aspects of mathematics and sciences, we're going to come across the relationship between quantities, which is displaying a linear or a nonlinear relationship, which of course is very fundamental for us to understand. So in that case, in trying to find the characteristics and behavior of a straight line or how we can derive one, it will be very important for us because it's upon this basis that we're going to understand those concepts. So without further ado, thank you and welcome. So as I've said, today we're going to look at an aspect of mathematics, which it is the equation of a straight line. So in our video of the introduction to geometry, we talked about the concept of a point. And then we talked about the concept of a line segment. And then we talked about the magnitude of a line. And then we talked about the coordinates. This basically is on the Cartesian coordinates. And then lastly we talked about the Pythagoras theorem. So in that case, if I just give a very small illustration of the summary of what we had talked about. A very small summary of what we had talked about. Just that. So that's make a very small summary of what we talked about. We said that we can have a point in space which is basically a small location in space that has got no length, width or height. And if I say this is point P, it's an arbitrary point in space that has got no length, height or width, and we call that one as a point. And the point, we said that can be illustrated just by calling it point P. Point P in space. And then a line segment, we said that consists of 2 points called endpoints, and the points and all the points between, and said that suppose we have another point, then the shortest distance between, or the distance between the 2 points, we can call it as a line segment. And for that case, we also talked about a straight line and defined it as the shortest distance between the 2 points in space, of course, which is PQ. Now in that case, we say that basically these points cannot be confined on this, and they might run or can run infinitely on both directions, whereby now this one gives us a concept of a line segment. So this is a line, and then the segment between P and Q is what we refer to as line segment, portion of the line. And then we talked about the magnitude of a line, whereby we say that suppose this line is demarcated in equal units on the number line, then we can find the magnitude of point P and Q irrespective of whether it is falling on the negative or the positive side of the number line. So that one gave us a concept of the magnitude of a line. And then we said that the orientation of this line, of course, can be anywhere in a 2-space dimension. So that is x, y. And suppose it's on a 2-dimensional space, which is x and y on the Cartesian plane, then we can be able to use a concept known as Pythagoras theorem to find the magnitude of the line A and B. Then lastly, we talked about a straight line, and we said that a straight line is the shortest distance between the 2 points. So today we're going to look at an equation, the equation of a straight line, which of course is an expression that is used to give the relationship between the expressions which are being given. For instance, if I say that A is equals pi r squared. This is an example of what we call an expression or just an equation. And someone can ask, what is really a, or just a pi square? So these two sets, or these two parts of this equation I've given is what we call, this is the expression, and this is an expression. So what basically is an expression? So in that case, it's a collection of symbols that jointly express an aspect of quantity. So it's a collection of symbols. Can it be a symbol or a collection of symbols, like in the second part of it, that of course jointly express quantity. For this case, I've just stated this is the area of a circle, which is equivalent to pi r squared. Of course, this is a constant and this is a variable. So for that case, the totality of this is what we call a combination of expressions which are just jointly expressing quantity, is what we call an expression. Now, from our topic equation of a straight line, we shall borrow from this concept of combination of expressions to make a statement that the values of the two mathematical expressions are equal. So in this case, as you can see that this expression, I've used an equal sign in between to state that a is equivalent to or equal to pi r squared. So the whole of this statement is what we call an equation. So in actual sense, an equation refers to a statement that says that the values of the two mathematical expressions that we have written for a and pi r squared are equal, and it's denoted by the sign, the signs of those mathematical sign of equation, which equates a quantity with another one. So in a sense, when we say equation of a straight line, then it's a relationship or a statement that is going to give values that some aspects of a line is equivalent to another one. So in that case, that's going to give us a simple definition of what an equation stands for. So we shall go ahead and try to see, as we said, that we can illustrate an equation on that particular two-dimensional space by x and y, and then maybe if it's a straight line from point A to B, and we say that if point A to B forms a right, let's keep this one just see, if it forms a right triangle, of course we said about a right triangle possesses 90 degrees at that point. So if it forms a right triangle, then the distance between this point and this one forms a displacement in the x, of course x direction, and this one forms a displacement in the y direction, the displacement from this point to this one. Again, we said that this is known as AB is known as the hypotenuse. This one can be referred to as opposite or the base or the height, and this one is the base. So if just right here, we said that displacement in x, displacement in y, and then AB, this is known as the hypotenuse. This is known as the height. And this one can be referred to as the base. Base indicating that the base of the triangle, the height of the triangle, and the hypotenuse of that right triangle. So I hope those specific terms are just okay. So in this case, when we're trying to look at the orientation of this particular triangle, we can see that if we look at the common geometry, that this is, if someone moves from point B to A, there's an inclination at a particular angle, let's call it angle theta. So this inclination is known as a slope. So in that case, the slope can be given as a value of change in the x and y axis. For someone to move from point A to B, you have to undergo an inclination. Of course, or moving from B to C, there's a declination from that point, given that it's moving from those points A and B or B to A respectively. So in that case, mathematically we can express this inclination. Of course, we call it the term, we give the term slope, and it is given as the change in y over change in x. So the change in the y direction over change in x is known as the slope. And then we said that the hypotenuse can be given using Pythagoras theorem, which gives the relationship between these three sides of a right triangle. So now in that case, the relationship between point A and B, or the displacement in x and y direction, is going to give us an expression or a statement that equates the values of course, these properties of a right triangle. So of course, I've said that the slope is equivalent to the change in x, the change in y and x direction. Then there's an initial that we use to denote slope, of course, which is given as m. So m is used to denote slope. So that's a new term. Let's do it with this. So therefore, we can say that slope, which is m, is given as change in y over change in x. Again, now we can refer to this slope as a gradient. Now the gradient, which is m, is equals change in y over change in x. So that's a new way. So we've moved from the slope to gradient given as letter m, the change in y over change in x. So suppose we give just arbitrary coordinates to point A and B and say that point A is xy. We have given coordinates to this point, and then point B is x1, y1. Then since we have been given general points for this case, then we are going to say that our gradient can be given as change in y. So y has moved from point y to y1, then we can say that change in y is y1 minus y, or the magnitude of y minus y1, divided by the change in x, which is x1 minus x. So this particular set of an equation can be used as the relationship of the change in y over change in x gives the formula for slope, and it can be used to denote the equation of this particular line, or the relationship of this particular line, given that the quantity, one aspect or expression is equivalent to another one, then that one will give us an equation. So doing a rearrangement of this, we can just say that therefore the relationship can be expressed as m into x1 minus x is equals y1 minus y. So this relationship that we have given, and we talked about the definition of an expression, this is an expression that is used given the coordinates of 2 points A and B to give the gradient, or to find the gradient of a straight line. So this is one of the ways in which we can express the equation of a straight line, A and B, given those two particular set of coordinates. So in that case, given endpoints A and B, then we can be able to derive an expression of a straight line using that format. There's something that I'd like us to mention before we move to that. So let's do away with this. So the equation that I've written down there, which was m into x1 minus x is equals y1 minus y. as we said, this is an equation that can demonstrate the equation of a straight line. This expression, of course, there are different formats depending on the orientation of this particular line that are used to give an equation of a straight line. And we're going to see different formats that are used. And one of them is that y is equals mx plus c, whereby we talked about the gradient of the slope and we defined it as change in y over change in x. So for this case, this set of an equation, this one represents the, just a minute, the expression y is equals mx plus c represents the equation of a straight line, whereby this one, as I've said, is the gradient, and this denotes sets of points, or just sets of points of a coordinate, like as I've said, xy. So this is just a general form of the points of the coordinate on that particular line. Any points of the coordinate on that particular line can be xy or x1, y1, etc. And this one is known as the y-intercept. Now from that intersection or just intersection, that one means that the y-intercept is a point at which that line, of course, cuts the y-axis. This is the x and the y-axis. So that line on the Cartesian coordinate whereby the line cuts the y-axis is denoted as the y-intercept. Now this form of an equation as well can be written in the form of ax plus by plus c is equals to 0. So there are some cases whereby you find that maybe, as we can see, one of the demonstrations that we have given, this line has got a slope. There are some cases whereby you can find that maybe the line is either parallel to the x or the y-axis. As I can give an example of maybe this line, just given dotted so that just for demonstration. Or maybe a line that is parallel to the x-axis. Then definitely the change, there will be no change for this line, there will be no change in the y-axis, and for this line there will be no change along the x-plane. So which means these two lines do not have, their of course expression will not contain that slope or gradient that we are talking about. Now there's a general representation, of course, for those specific kind of lines. There's a relationship that is given which gives the relationship between the quantities of that. We shall look at that later. So in general terms, we can say that the first one, which I've given here, gives the general expression of a straight line that can have a gradient. And secondly, for this case, we find that it also gives the expression of a straight line whereby maybe the two lines, either the x. Now, as we have the y-intercept, we also have the x-intercept, and either values, when we are talking about lines parallel to x and y axis, either values for x and y can be 0. Now, for that case, we're going to look at that one, of course, in details when we're trying to give an expression of the same. So for instance, let's look at the concept that we have talked about, that given the points on a straight line, one can find either the equation representing that line or maybe the coordinates along that line. So suppose we have an equation of a line that is passing through point P. Okay, let's say that this is point. Okay, just give just an arbitrary line without showing its orientation. Maybe it's point P to Q. Let's try to use our concept and see whether it works. So suppose there is an equation of a line that is passing through point 2, 2, 4. These are the coordinates, and then Q is 8, 7. Let's try to see whether we can be able to find the equation of that particular line. So we said that we can just allocate these points by generally giving them course giving them just arbitrary figures. Let's say that this is point x1, y1, and this is point x2, y2. And we can be able to find the slope of that point by trying to find the change in y over change in x. So using this equation that we had said that m into x2 minus x1 is equals y2 minus y1. We can use that expression to find maybe the equation of that gradient. And this one can be reduced to the form, of course, we say that m is equals y2 minus y1 over x2 minus x1, whereby m denotes the slope or the gradient of that particular line. So trying to see from these coordinates that we have been given, then we can be able to say that the change in y is 7 y2 minus y1. So 7 minus 4, of course, we can just do a replacement for that. 7 minus 4 divided by x2 minus x1. This is 8 minus 2, which is going to give us 3 over 6, which is equivalent to a half in simpler terms. So in that case, if we've got the equation of a straight line, as we said, the general expression for equation of a straight line as y is equals mx plus c, then we have found m. So we're going to do a replacement for that and say that y is equals a half x plus c. So at that point, we said that the n set of points, that is for x and y on the line, can be able to be substituted and find the equation of that straight line, of course. So in this case, we have 3 unknowns. We can just do just a simple substitution. Suppose we take this point here for x and y, then in this expression we can say that 4 for y is equivalent to a half, so x is 2 times 2 plus c. So this one is, since c is the unknown, we can be able to find c and then say that this is a half cancels with that. So this is 4 is equals 1 plus c, implying c is equals 3. C is equals 3. So substituting for that, then our equation becomes y is equals a half x plus 3. So which means the y, this line cuts the y axis, or the y intercept is 3. So this equation is in the form of y is equals mx plus c, where m represents the gradient of the slope and c is the y-intercept, which is a constant, of course, given generally as that. So in that case, we can say that a straight line can be completely be determined if its direction is known and a point is given through the line that we, of course, mentioned. So we are just going to give a summary of the definitions that we have talked about on representation of equations of a straight line. And then we're going to finish it with giving a general term. So as we have said, given general points, maybe points P to be x, y, and Q to be points x1, y1, then those 2 points can give us an equation of a straight line illustrated by y is equals, or just y minus y1. this is absolute value, so it can just go either direction. So y minus y1 is equals m into x minus x1. So this is equation 1 of just illustrating the equation of a straight line. If a line passes through the points P and Q, whose general, of course, whose slope is given as m, which of course we said is a gradient. Now this equation of a straight line having the slope m, and then we said it can be given as y equals mx plus c, whereby c denotes the point at which the line cuts the y-axis, which is known as the y-intercept. So in that case, in that case, of course, the gradient on that line, of course, at the end, two specific points chosen, it's just going to be the same. Now, suppose we say that if a graph is like that, that is the x and y, and then there's a line, of course, a straight line of that nature, and we'll find that the displacement in y is equals to 0. And if we look at this, of course, not y actually. So this is the change in y. Just a minute. So we said that suppose we have a point of this nature. If we are trying to find the gradient, so this one is just derived from the general formula of ax plus by plus c equals 0. So that form of a line is used to find the relationship between to express the equation of a straight line, of course, which is either parallel to the x or the y-axis. This is parallel to the y-axis, whereas this one is parallel to the x-axis. Now suppose a is equivalent to 0, then you will find that the expression for that line will be given as py plus c is equals 0, implying that the y-intercept will be equivalent to minus c over p, indicating that the line is horizontal and parallel to the x-axis. So in that case, the one that I've indicated for this will be given by that. So additionally, suppose there's the b is 0, then the equation for that particular line will be given as ax plus c equals 0, whereby c will be equivalent to, or just the x-intercept will be equivalent to negative c over a. So which means this first set of a line that we have given, this one, which is parallel to the x-axis, just an horizontal line, whereby that aspect of the expression for, of course, a is equals 0 and for b is equals 0 respectively. So that one, these two categories, of course, they are going to be expressed using a general term or the general formula, because this equation that we have we've been given, which is having an aspect of a gradient, cannot be used to express this set of two lines which are of course parallel to the x and y axis respectively. So what does that one mean? So that one means that we have different ways of expressing this equation of a straight line, as I've said, and one of them has a characteristic of a gradient that we have tried to give an example for. So that one is going to give us a clue on how to find expressions of a straight line if one we come across them. Now, as we said that these expressions of a straight line are going to assist us in finding some relationships, or suppose we are just trying to analyze our data and it gives us a linear relationship that we can be able to express in the form of y is equals mx plus c. Then finding the gradient of that representation of the data distribution that maybe we are expressing in terms of the y and x coordinates, then we can be able to try and see how the data has got a relationship. Of course, this is application of this aspect of a straight line, and as we have said, this is a general way in which we can be able to express them. Of course, we are going to give different examples as we go ahead so that they can be able to assist us understand more. Now, simply it was an aspect of us trying to see on how we can be able to derive a gradient and how we can be able to explain the characteristic of a straight line that has got maybe an inclination for a slope and the two lines which are parallel for this case. And we have said that for a straight line that has got a slope, we use that equation to express it. And for a line that is parallel to either the y-axis or the x-axis, this general formula is applicable. Now, it is true that we can be able to just express one expression. Given an equation, we can be able to express that particular equation in a different form of a formula that we have stated. Suppose I give an example that if a straight line of the form y is equals mx plus c is given as y is equals 4x plus 9 equals minus 9. So from this we can say that the gradient is equals 4 and the y-intercept is equals 9, and the points, maybe we can just find the points on a straight line, another point or a set of points, by just using the x and y coordinates. So in that case, if this form of a line is expressed in terms of y is equals mx plus c, can we be able to express it in terms of a second form that we said of ax plus by plus c is equals 0? So let's try to see this. So in this case, then we can say that, okay, this is the solution. So if you are told to express the equation which is in form of yx plus c is equals this in terms of this representation, then we can just do a rearrangement and say if y is equals 4x minus 9, then it can be written as y is equals, or just y, we can take this part of an equation to the other side, it will become negative, y minus 4x is equals minus 9. And then ensuring that there's a 0 on the other side, we just take 9 to the left side of the equation, and then we find that 9y minus 4x plus 9 is equals 0. So in this case, we can equate this equation to this and say that we have expressed an equation which is in form of yx plus c in terms of ax plus by plus c is equals 0. So this is a way in which we can do an interchange between expressions given one of them, and try to see whether we can be able to develop a relationship which we have been asked. So basically the y-intercept is a point, as we said, at which the line cuts the y-axis, and from there we can of course be able to develop other relationships as need be. So in that case we're going to wind up at that particular point, and I hope that we have understood the relationship between those particular Cartesian coordinates that we have given. And given up maybe 2 points, one can be able to express the gradient or the slope, and can be able to derive the slope from those two arbitrary points given on the Cartesian coordinates. So that is it for us today, guys. So thank you. God bless you. Bye.